Hi everyone, in this video I'm going to show you how to implement basic algorithms for searching and sorting arrays. But to understand the materials showed in this video, you must have learned basics about single dimensional arrays. So before watching this video, please make sure that you have watched my previous two videos about arrays in Java, part 1 and part 2. Let's get started with searching arrays. The searching problem is one of the basic problems in computing. It's in almost every application that you are using. For example, searching for a word in a document or searching for a username from a user database. To solve the searching problem, we first need to define it by specifying its input and output. The searching problem takes three inputs, including an integer n, an array A of at least n elements, and a value target, which is used as the search key. The problem is to find an element in the given array that equals the given target value. Typically return the index of the element found. So the output of the searching problem is an index k between 0 and n minus 1, such that the element of the array A at index k is equal to the target value. If there's no such an element found, then the output should be the answer not found. Here is an example or instance of the searching problem where input n equals 8, targets equal 15, and the array A is given as in this array. Note that here array A has 10 elements, but we are supposed to search within the first 8 elements only because n equals 8. The correct output of this instance is 5 because the element at index 5 in the array is the first element within the search range that has a value equal the target value. The most obvious way to search an array is to look up its elements sequentially from the beginning. This is known as the linear search algorithm, which is to solve the searching problem. It's very straightforward, but actually optimal for unsorted arrays. Here is the algorithm outline of linear search. So in the first step is scan the array from index 0 to index n minus 1. And during the scan, it compare the current element with the target value. If the two equals to each other, then stop and output the current position. That is the current index of the current element or the index of the current element. So if we didn't get stopped during the first stop here, the first step here or the scanning step, then it output not found. And for example, suppose we perform the linear search on this given instance of the searching problem. Then first we check if A0 is equal to a target. If not, then check if A1 is equal to a target, and so on until we reach A5, which equals target, and we stop and output the current position, which is 5. Now that you have understood how the linear search algorithm works, we can implement it in Java. This method implements linear search on array of int elements, but its header can be modified for arrays of other types. The method takes three parameters corresponding to the three inputs of the searching problem. The first parameter is array parameter A. The second one is parameter N. The last parameter is the target value. The method body has a simple for loop that goes through the elements of the array parameter from index 0 to index n minus 1. For each element, it checks if the element equals target, and if so, it returns the index of that element. Then it returns minus 1 after the for loop. The output value of minus 1 indicates that no element is found. If an element is found, the output value would be non-negative. Sorting arrays is another basic problem in computing that we use in many applications every day. Here we consider the sorting problem, that is to sort the first n elements of an array A into non-decreasing order. So the inputs of this problem include the number n and the array A. And we have to rearrange the first n elements of the array A so that A0 is less than or equal to A1, and so on. Note that the array A can have more than n elements, but having the input n allows us to sort a partially filled array. And there are many sorting algorithms. In this video, I'll show you one of the elementary sorting algorithms known as selection sort. The idea of selection sort is to reduce the unsorted array segment by one element at a time until the unsorted segment has only one element. We use a variable start to keep track of the index of the first element in the unsorted array element. So initially the entire array in the input is considered unsorted. So variable start receives value 0 initially. Then each time the unsorted array segment is reduced, we increase variable start by 1 until it reaches the value of n minus 1. This algorithm outline shows the loop with variable start being the counter controlled variable, and the body of the loop shows the steps to reduce the unsorted array segment by 1. The first step is to find the smallest element in the current unsorted array segment, which has index from start to n minus 1. Then swap that smallest element with the one at index start, which is the first element in the current unsorted array segment. After swapping, the first element in the current segment is already in the right position, so we can remove it from the unsorted segment in the next iteration. Now I'm going to show you an example of how selection sort works. Suppose we use selection sort to sort the first 8 elements of this array, which has 10 elements. But the last 2 elements only have default values, so we don't want to sort them. So at the beginning, when start equals 0, the unsorted segment is from index 0 to index 7, which is n minus 1, where n is equal to 8 in this case. Then we look for the smallest element in the unsorted segment, and it's at index 3. So we swap the element at index 3 and the first element in the current unsorted segment, which is at index 0. After swapping, variable stars increases from 0 to 1, which means that the unsorted segment is now from index 1 to index 7. Then we looked for the smallest element in the current unsorted segment and find it at index 5. So we swap the element at index 5 and the one at index 1. After swapping, we move to the next iteration with start equal to 2. At this point, the first two elements of the array has been sorted, and the unsorted segment is from index 2 to index 7. We look for the smallest element in the current unsorted segment again and find it at index 5. So we swap the elements at index 5 and index 2. And after swapping, we move to the next iteration with start equal to 3. At this point, the segment consisting of the first 3 elements is already sorted, and the unsorted one is from index 3 to index 7. So now when start equal 3, we look for the smallest element in the current unsorted segment again. And in this case, it is also the first element, but we still do the swapping. So here, the swapping, it would not take any effect, but the algorithm still performs it. And so after swapping, we move to the next iteration with stars now equal 4. And so the unsorted segment is now from index 4 to index 7. And again, we looked for the smallest element in the current unsorted segment, and it is at index 5, and then we swap it with the first element of the current unsorted segment. And after swapping, we move to the next iteration with start equal 5. And so the unsorted segment is now from index 5 to index 7. And again, we look for the smallest element in the current unsorted segment, which is at index 7. And we swap it with the first element of the current unsorted segment, which is at index 5. After swapping, we move to the next iteration with start equals 6. And now the smallest elements is also at index 7. So we swap it with the first element of the unsorted segment, and after swapping, we move to the last iteration with start equals 7. So note that the loop stops when start equal n minus 1, which is 7 in this case. And at this point, the unsorted part has only one element. So no need to do any swapping or looking for the smallest element. So the loop body is not executed when start equals 7, but the last element here is also the largest element in the original array segment. So the anti-array segment from index 0 to index 7 or n minus 1 is now sorted. Okay, so now that you have understood how selection sort works, we can implement it in Java. So we just write it as a method named selection sort. You can put this method in any class if you want. And so in the method body, it has a for loop so that corresponds to the for loop for starts from 0 to n minus 2. So the condition for the loop to continue here is start less than n minus 1. And here n is the second parameter of the method, and it is assumed to be less than or equal to the length of the input array. So in this for loop, it has two steps corresponding to the two big steps inside the loop of the algorithm outline. Right? The first step is to find the smallest element in the unsorted segment, which is from index start to index n minus 1. So the algorithm to find the smallest element is trivial. You use the variable min index to keep track of the current element. So sorry, the index of the current smallest value. Right? So initially you start you assign min index to the first index of the unsorted segment, which is equal to start. And so the mean value is equal to the element at that index. So mean value is always equal to the element, the value of the element at the mean index. Okay? So then we use the for loop to loop through the remaining elements in the unsorted segment to update the mean index and mean value. So whenever we find an element that is less than the mean value, then we update the mean value to be equal to that element. And then we also update the mean index to be equal to the index of that new element. Well, so after this code segment, now we have found the index of the smallest elements, which is stored in the mean index, and mean value is equal to the array of mean index before the swapping. So now yeah, the swapping consists of two assignment statements. The first one is to assign array of mean index equal to array of start. That is, you put the value of the element at index start into the element at index mean index. Okay, and then you put the mean value into the element at index start. But note that the mean value here already holds the value of array at mean index before the swapping. So it's not if you use array mean index uh, in the place of mean value here, it would not work because the array of mean index has been modified by this assignment statement. So note that this is a more general implementation of selection sort, which sorts for partially filled array. You can look at the live example, which is selection sort.java from the textbook that show just the selection sort on the entire array, uh, which works similarly, except that you replace n with array.length. Finally, here is some small exercises that you can do to practice with sorting yeah, arrays in Java. So here I gave you this array, okay, also has 10 elements. And so suppose that we ha we have declared and graded that array using this assignment statement and declaration. Okay, so you need to write a call to the selection sort method to sort the entire array. Okay, assuming that I gave you the method named selection sort as in the previous slide. Okay, you just need to call it. You don't have to rewrite it. The second exercise is to describe the content of the array A after each iteration of the outer for loop in the above method call. That is the method call to selection sort.